dear students, as a part of your fifth semester, you have to study electricity, magnetism, and electronics as a fifth year paper. Before going to the syllabus, let us discuss some 2 points about static electricity. Of course, you learned all these things in your previous classes. My lecture will help you to recall your previous knowledge. As the name indicates, static electricity is a branch of electricity in which we discuss effects due to static charges. Effects like electric potential, electric field, electric flux, etc. We will discuss in these topics. We know in every material there are two types of charges: positive charge and negative charge. Of course, we know like charges repel each other and unlike charges attract each other. In order to calculate with how much force they will repel or attract, Coulomb proposed a law, that is Coulomb's inverse square law. I start my lecture with Coulomb's inverse square law. Let us see what is Coulomb's inverse square law. According to Coulomb's inverse square law, force of attraction or repulsion between two charges is directly proportional to product of the magnitude of the two charges and is inversely proportional to square of the distance between the charges. That means F is proportional to Q1 Q2 by R square, or F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. Here Q1 Q2 are the magnitude of the charges which are expressed in coulombs, and R is the distance between the charges which is expressed in meters or centimeters. Also, epsilon is the permittivity of the medium. Permittivity means it is the measure of the material's ability to resist electric field. That means if we need a strong electric field, we choose a medium with low permittivity. And epsilon is the permittivity of the vacuum. Its numerical value is 8.85 into 10 power minus 12 Coulomb square per Newton meter square. And 1 by 4 pi epsilon naught is equal to 9 into 10 power 9 Newton meter square per Coulomb square. These values are very important in solving the numerical problems. So from this description, you understood every charge influence the other charges. That means there is some attraction or repulsion between the charges. But this influence exists up to a particular reason, because the force of attraction or repulsion is distance dependent. So this influence exists up to a particular region. This region is called electric field. Let us see what is electric field. Electric field is defined as a region around an electrically charged particle in which an electric charge would feel force. So around every charge, it may be positive or negative. Around every charge, it influence exists up to a particular region. This region is called electric field. In order to understand electric field in an easy way, we assume some lines of forces. These lines of forces are the paths of the motion of the positive charge in the electric field. So suppose if the field is formed due to positive charge, we take these lines of force in outward direction. That means if the field is formed due to negative charge, these lines of force are directed in inward direction. Let us see the situation. It is the electric field formed due to positive charge. So these lines of force are directed outward side. This is the electric field formed due to negative charge. So these lines of force are directed inward side. So it is clear that every electric field is filled with some lines of forces. Suppose if we place some other charge in the electric field, from Coulomb's law, definitely this charge will experience some force due to the electric field. The force experienced by this charge is called intensity of the electric field. Let us see what is intensity of the electric field. Here is one of the important topics in this static electricity. Intensity of the electric field means force acting on a unit positive charge in an electric field. That means if you place another charge in the electric field, it experiences some force due to the electric field. This force is called intensity of the electric field, which is expressed as E is equal to F by Q, and which is expressed in Newton per Coulomb or volt per meter. The direction of the intensity of the electric field is taken along the direction of the motion of the positive charge. This intensity of the electric field is expressed as E is equal to 1 by 4 pi epsilon naught Q by R square. Le- uh, Let us see one more important topic in static electricity, that is electric flux. Electric flux means we already discussed every electric field is filled with some lines of force. Uh, Suppose if we take some surface in the electric field, these lines of force travel to the surface. Uh, uh, the number of lines passing through this surface in a direction normal to the surface is defined as the electric flux, which is represented by pi, and this is expressed as electric flux pi is equal to E dot A or EA cos theta. Here E is the intensity of the electric field and A is the area of the surface, and theta is the angle between intensity of the electric field and the normal drawn to the surface. It is also expressed as phi is equal to integral E dot ds. Here ds is an infinite Simon element. E dot ds is the electric flux through ds area, and integral E dot ds is the electric flux through the entire surface. From these equations, it is clear that flux is maximum when theta is equal to 0, and flux is minimum when theta is equal to pi by 2. Let us see one more important topic, that is electric potential. Let us recall in case of thermodynamics, heat travels from high temperature area to low temperature area. Similarly, there are similar topics in static electricity, which are current and potential. As in case of thermodynamics, heat travels from high temperature area to low temperature area. In case of electricity, current flows from high potential area to low potential area. Let's see what is electric potential. It is an electric field formed due to positive charge and negative charge. Suppose if we want to bring a positive charge into this field, what happens? This field is formed due to positive charge. So, according to Coulomb's inverse square law, these two charges repel each other. So, if we want to bring this positive charge into this field, we must do some force against the field. This force is called electric potential. So electric potential is defined as the work done to bring a positive charge from infinity to a point in the given electric field, which is expressed as V is equal to W by Q, or V is equal to 1 by 4 pi epsilon naught Q by R. So it is clear potential is totally distance dependent. That means potential varies from point to point in the electric field. The difference between potential between 2 points in the electric field is called potential difference, which is expressed in terms of volts. So what we discussed today, we discussed the Coulomb's inverse square law, what is electric field, what is electric flux, intensity of the electric field, and potential. All these topics are very important to understand the first unit in fifth year paper. Yeah. Please observe all these things. Thank you.